idealo, and I'm very much looking forward what he has to say. Welcome on stage.
Thank you very much. Yes, it's great to be here and great to see so many people from the industry and exciting conversations. It's a beautiful venue, so yeah, it's really a pleasure to be here. And today I want to talk a bit about our learnings from working with large language model and product development, and I want to reduce it to 3 key learnings. So keep it light. Maybe a quick show of hands. Who has used idealo before? Okay, so that's quite a lot, so that's cool. It's mainly a price comparison website, right? We're in 6 European countries. Germany is by far the biggest market, but the mission really is to allow users to have a transparent buying experience, right? Online shopping with hundreds of thousands of shops available, dynamic pricing, we just heard it. Sometimes it's very difficult to make an informed and good buying decision. At idealo, we have contracts with over 50,000 shops, and we try to help you there. And we have the big marketplaces like Amazon and eBay in there, but also Otto, but also like the local sort of like shops within your city or in your area. They're all listed on idealo, so you get a good market overview. In total, there are over 4 million products, over 500 million offers that we map to products, a lot with machine learning actually. And so there's a lot going on. That's enough about idealo. So before we delve into the key learnings that we made while working with large language models, I just want to briefly give an indication of where generative AI is at. And Connie, of course, she gave like a much better insight just now, but it's just really like a nice model that I like, and it's this hype cycle that you've maybe seen before. It's derived from Gartner hype cycle as well. This is like a simplified version. And on the vertical axis, you have expectations, and you have a horizontal time axis. And usually when new technologies come up, you have this hype, right? And these inflated expectations. And then there is this trough of disillusionment. You know, people realize, it's actually not that easy, and it's probably not all powerful, you know, and then usually after a while, you reach a plateau of productivity, right? So we've probably seen it with dot-com bubble in the early 2000s, you know, internet, you know, a lot of hype. Then it just kind of like went downhill, and then it became sort of like productive, very productive. And the same happened with traditional machine learning, I would argue 7 or 8 years ago, right? Where, you know, there was a lot of hype, but it took a few years until it became really productive within companies. And the same, of course, is happening with generative AI. And if you look at the industry and if you talk to people, I would argue that we are behind the hype peak, you know, and we are kind of like, a lot of people are realizing, okay, it's really hard to create business value out of generative AI. So I'm really talking mainly about sort of customer-facing applications. Of course, there are a lot of process optimization possibilities, and it's immediate. But to really integrate it into your product development in a productive way, it's actually a lot harder than a lot of people thought, I would argue. So my mission with the 3 key learnings is to maybe transition a little faster into this area of enlightenment and productivity. So if I can manage that, then I'm happy. First learning for us was that you really need to focus on user needs and the strength of these large language models, right? Because even with generative AI, you need to start with a user, like in all product development, but it's easy to forget that sometimes if there's so much excitement around that, right? So 2 years ago, you know, when we kind of like ChatGPT came out, there was so much excitement, and management asked us, okay, we need to do something here. If you asked around, everyone said, oh, you need to build a chatbot, a shopping assistant, right? So that's, and we, of course, yes, let's do it, you know, when we built a prototype and we user tested it and pretty quickly found out, okay, this is actually not really what the user needs, right? Or at least our users don't necessarily want to type, for example. They don't want to read a lot of text, you know, they have a very short attention span. So like a chat interface was actually not really what was addressing any user problems in our case. So really as always, start with the user problems and then try to focus on some of the large language model abilities, right? So they can do so many things, and you see all these great prototypes and blog articles, and it's just so inspiring. But on the other hand, it's like, do you really need a large language model to do arithmetics, or do you really need a large language model to do traditional classification tasks for which maybe like some simple linear models might be sufficient, right? So it's sometimes a very big hammer for a small nail, and you need to be aware of that. And ideally, at the intersection of these two, or at least that's what we did, we really started to map these abilities of these large language models, so this language understanding, the ability to summarize, to put really natural language into a structured format, all of these great abilities, we started to map these two opportunities we saw and how to address user needs. And if you then sort of prioritize by the degree to which you leverage these large language model abilities and also the business impact you can potentially take, then you're on a good path. And the third dimension here is feasibility. So you need to be really quick. Once you've identified some potential use cases, you need to be really quick in trying them out, right? And really rapid prototyping is the buzzword here, and you really just don't waste any time, just build something quick and dirty and see whether you're onto something. And yeah, there are many great playgrounds out there. I mentioned the Bedrock playground that we use quite a lot because we are mainly on the AWS sort of platform. But yeah, you have the same with OpenAI and other providers, of course. Even product managers, it's no code, everyone can do that pretty much. And once you've checked feasibility, you built your first prototype, then it's very important to kind of like build your MVP and start user testing. Show it to users as early as possible. And we actually showed this chatbot or other applications in qualitative user tests, or we also had a conference and we just randomly showed it to conference attendees. We just wanted to get very, very quick user feedback. And that's invaluable because you learn so many things. And yeah, and once you're kind of like in the middle of those three kind of dimensions, I think the probability that you can move a prototype into production is a lot higher, at least from our experience. Okay, I quickly want to give an example of one of the large language model powered applications that we built on idealo. And this is a standard product page on idealo, in this case for an Apple iPad. And one of the customer needs that we have is that users want to quickly compare products, right? So for example, if they're looking at an iPad from 2022, they want to know what is the difference to the iPad from 2021, for example, right? And this is sometimes a pretty daunting task. And on this product page, we have a really long list of product attributes down the bottom, right? And it's like 60, 70 attributes. And if you then have to compare it to the previous year's iPad, right? This is a really tough task. And we know that this is a user problem, right? It takes a lot of capacity and users just usually Google or do something else, but they leave idealo. So we identified user needs, and we also identified some large language model abilities that can help us here. So these large language models, they will, for example, look at these long lists of attributes, and they will extract the most important ones for this specific comparison. So here you can see we're comparing 3 iPads. And it will, out of 70 attributes, it will, for example, extract 6 or 7 meaningful ones for a comparison table, for example. And you can just prompt it in a way that it's especially relevant for this comparison. So for example, I'm just going back. With iPads, maybe something not super obvious might be the weight of the device, right? And which is the second from the bottom here. And it's actually, but actually, if you think about it, yeah, actually this might be quite interesting for users, and you want to understand which one has the lowest weight, for example. And the large language model in this case picked it up. Then we also want to highlight the differences, right? So we want to know, okay, is a lower weight better than a higher weight, right? Or is a higher camera resolution better than a lower camera resolution, right? And of course, you could create all of these rules and create a rule-based system. It takes a lot of effort, and it's very difficult to maintain. A large language model understands these differences, and it knows that a lower weight for tablets is preferable and has higher customer value. So we are exploiting this ability in this comparison table, for example. Second key learning. And this might be a bit cryptic, but what we realized is that for our product development, it's actually beneficial to not think of large language models as this all-encompassing knowledge machines, but more as a language interface. And a good example might be what we just saw with ChatGPT, right? With ChatGPT, usually when you interacted with it, you could ask it all kinds of questions, and it has this vast knowledge on so many topics. But it's of course also very dangerous because it might hallucinate, and it might hallucinate in a very convincing way, right? So it's actually, people lose trust, and for really important decisions, and of course there are more important decisions than buying a tablet, but at least you're spending money, so you want to trust whatever this service might tell you. And there ChatGPT is actually, users don't really trust it for these kind of decisions yet. But then they introduced now Search GPT, right? So the search functionality within ChatGPT. And that's basically, it's doing a web search in the background, and then it's generating the answer based on the search results, and it's also giving you the references, the links to the pages it found, right? And this is what we mean is that this is more a language interface now, because you can query that language in that machine in natural language, but you're not relying on the world knowledge. You're relying on a web search and actually some articles that it pulled up. And that's pretty much the same concept that we use in a lot of the products that we developed. So we don't rely on world knowledge, but we rely on our proprietary data. So I'm going to give an example. Again, this is now a product category overview page. So here's my cursor. And in this case, it's Wäschetrockner, so tumble dryers. In case, it's just one of the examples, but you can see a bunch of different products here. And you can see on the left, we have this really long list of filters, right? So it's manufacturer, it's energy efficiency, it's all kinds of filters you have there. And it's quite daunting for users. Again, where do I start to filter my products? If you're not an expert in tumble dryers, you don't necessarily know how best to narrow down your search results, right? And then, which is a bit paradox, but we actually on idealo have really good Ratgeber content, expert knowledge content at the very bottom of the page, but hardly any user goes there, right? So, but this is really good content in order to make a buying decision, but it's not readily available for the user. So one GenAI feature we developed, and this is actually live on the web page, and this is part of an A/B test now, so you need to be in a certain variant. So if you go on idealo and Wäschetrockner, you have a 50% chance that you will see this. But now it's kind of like this feature is kind of showing you a question and also answer options. So welche Art von Wäschetrockner suchst du? And then, it's kind of giving you already some answer options, and it's also giving you a bit of like an explanation here at the bottom. But we are basically using whatever we explain here and the insights, and also what we ask first, we use our expert content from the bottom of the page. But we just use the large language model to create these questions and answer options and to allow this flow, which wasn't possible like that beforehand, right? But very quickly, by answering like a few questions, you could narrow down your search results quite significantly. And it's like anyone without a lot of category expertise can answer these questions. So can we switch back to the presentation? Thanks. So let me just show you a little bit in terms of like the prompting techniques that we use to create this product finder that you just saw, and the concept of using our proprietary data for that. So first we have a prompt, I called it next consideration, which is basically trying to find out what is the question I should ask the user now to narrow down their search results. And if you just get started, it would be this: what type of Wäschetrockner are you looking for, right? And for this, we give the context of this Ratgeber that I showed you before, this expert content. And we put it into the prompt, and we just, we give some instructions, and then the large language model gives us, hey, you should focus on the type of tumble dryer first. So this would be the output next dryer type. Then we have another prompt where we actually map this information now, dryer type, to the available filters that we have on this category page. So, we have this vast list of filters, but now we do the mapping exercise. And we take a large language model for that again, because it's very good at that. And it can translate dryer type to our available filter product type. So it does that very reliably. And so now the output is, hey, you should use the filter product type, and it has a certain array of values. And with this information, we then start generating the question and the answer options. And this is then the output you basically get and that you see on the category page. So this is just giving you a bit of an insight on the prompting structure we're using there and how we leverage our data and use large language models more as an interface than as a database. Okay, I'm going to skip this example out of timing reasons. Let me come to the third and last key learning, which is evaluation. And what I've seen also in traditional machine learning problems and just in the same way now with generative AI products is that evaluation is key, and it should be one of the first principles before you start with a project. You need to make up your mind, how are you going to evaluate its performance? Again, it's more difficult with generative AI developments because it's more fuzzy, right? How do you measure the quality of a question? How do you measure the quality of an answer option? How do you measure the flow of such a product finder, right? So it's very fuzzy, and it's difficult, and that's why a lot of times this gets neglected in the beginning when you start building start developing. So, but what we've seen, as soon as we have product types and prototypes, and as soon as we start to scale it up, the bottleneck is always that we cannot evaluate it quickly enough, and we cannot iterate in an informed way. So it really needs to be at the forefront before you really start actually putting a lot of development effort into your solution. You should probably put as much development of effort into the solution as into the evaluation. And there are certain ways and techniques how you can evaluate these models, right? So it could be something rule-based. So you can, for example, for the product comparison, we could just check whether the actual values for the products are within this comparison table. So this would be rule-based. You could also, for example, if it's more a named entity recognition problem, you could also refer to more traditional machine learning metrics like precision and recall, right? But for example, with something like a product finder, which is more fuzzy, a lot of people use this concept of LLM-as-a-judge. So basically for the evaluation part, you use a large language model again, and you create a prompt where you instruct the model to look at the output of the other large language model, for example, this product finder, and you just ask it to assess its quality, its relevance, whether it followed instructions, whether it kind of like didn't hallucinate anything, all these kind of things. So you can use another, basically, large language model to be a judge. And this is a quote from a really nice kind of blog post that I found, and that reflects our learnings as well. It works to some degree, but it's definitely not a silver bullet. And you need to spend a lot of time to actually tune your evaluation prompt to make it useful. This is, for example, here a prompt that we used to actually do evaluations, and you probably can't read it, but this is from the product comparison use case, and basically, just to give you a feeling for the structure, we give it all the product attributes that are being used to create this comparison table. We give it the actual prompt that was used to generate the table, and we basically ask, hey, are there any severe errors? And if so, give us the kind of give us like an explanation of why this is wrong and how it could be corrected. So after you run this, you basically have a judgment on how well the model performed its task. And with that, you can build your metrics on top of that. That's all I had to share, these 3 key learnings, and open to questions now.
Thanks a lot. Are there any questions in the audience? Wow, wonderful. Yes.
First of all, thank you very much for the great insights and great presentation. as far as I understood, you use an, let's say, hybrid approach to lower or avoid hallucinations, like the searching-based approach and so on. So is there any guarantee that you don't have any more hallucinations?
I wouldn't say there's a guarantee, no. But I would argue that, for example, with the product comparison use case, and that's actually something we worked on last year, that we still manually went through hundreds and hundreds of examples, and in the end we got like a really high confidence level that there are 0 hallucinations. So we couldn't find any hallucinations within hundreds and hundreds of examples. But it was also a really interesting journey, because back then we started with kind of like, it was GPT-4 back then, and then you had Claude 2.1, for example, and actually we started with Claude 2, from Anthropic, these models, and Claude 2 hallucinated quite a bit. And we found these, and we thought, okay, this is a deal breaker, we can't use it. Then Claude 2.1 came out, and we could immediately, in our use case, really see the difference in hallucinations, So it's like you saw it in the blog articles and the community reporting, it got much better at avoiding hallucinations. And we saw exactly the same in our evaluations. So by now, we don't have a guarantee, but with this approach on basing it always on our data, we are quite confident.
There was a question over there as well.
Yeah, first of all, thanks a lot. You're the reason my television was 30 euros cheaper. But I also have a question. It's quite specific, to be honest. At the bottom of your last slide, I guess there was the end of a prompt. And I just wanted to know, when you do things like this, do you prompt that it should give back a certain format? So when you put the whole LLM into a, let's say, pipeline, do you prompt it as like, give me back something technically I can use? Or do you use some, I don't know, API to, I guess you got the question, right? So how do you integrate it into your pipeline?
Yeah. So if I would have had the time for fourth key learning, the fourth key learning would have been to always use structured output formats. So it's, for us, like, it's really key. Whatever we ask the LLM to produce, it should be in a structured format. So we use JSON quite a bit, but we've used also XML formats that we can then use downstream with some other logic, or to feed it into another large language model. So it's always structured output. And of course, it's a very dynamic area again. So with the OpenAI models, you have a JSON mode now, which actually is like a strict schema mode, which really follows your JSON schema key by key, right? So you're guaranteed to get your desired JSON output. It's not only a valid JSON object, it actually follows the exact schema you give it. Anthropic is actually not that far when it comes to the strict schema format, but nowadays it's almost 100% accurate in generating whatever schema you want.
Thanks.
Okay, quick third question. Yes.
Thank you very much for this really nice presentation. You explained how you're measuring the performance of the machine learning approach, I would say now, with different parameters. How do you now translate this into business value? So how do you, or is idealo somehow measuring the cost savings or the impact, or deriving some implications from what this actually brings?
Quick answer.
Yes, I mean, the quick answer is that, like in the demo I showed, right, it's an actual live A/B test that we are running, right? So this is actually within an A/B test. So this is a variant you see, and the control group, for example, doesn't have this product finder there on the left. And there, of course, we measure the business KPIs, bounce rate, conversion rates, all these kind of things, and we see the difference between the two.
Thank you.
Maybe also an interesting barcamp session. Who knows? So bring it up later when we brainstorm for the barcamp. Thanks a lot, Christopher.
Thank you.
I'll keep that.